All right, let's do problem number 3 of this, this worksheet here. And the problem says a 50 kilogram crate is pulled across a flat, frictionless horizontal surface by a force of 30 newtons applied horizontally. A, what is the acceleration of the crate? B, how fast is the crate moving after 5 seconds? And C, how far did the crate displace in 5 seconds? Okay, so let's zoom out. Take a look at the board. Oh, this board's very well organized. I like it. All right. Okay, so here's what's given. We have a 50 kilogram crate. It's being pulled with 30 newtons to the right. There's no friction. They wrote that down. And the force, the 30 Newton force, is horizontal. So they correctly visualize the problem. This is really important. Then, so given, find acceleration, well, really the velocity after 5 seconds, and then the displacement. And then let's solve. So the first thing we do is we draw a free body diagram of the 50 kilogram crate. We don't draw the floor is over here, but here, Earth is pulling down on this 50 kilogram crate, but the ground is pushing up with a normal force. And then, of course, we have this 30 Newton applied force. Okay, so now the nice thing about this is that, well, remember, you got to tell me your x direction and y direction. But the nice thing about this problem is that all the forces are lined up with the x and y axis. So we don't need, to break the force into x and y components. We don't need sine or cosine or any of that. So this problem's a little bit easy. So we're going to add up the forces in the x direction equals ma in the x direction. There is only one force in the x direction, and that is this 30 Newton force. I look at my free body diagram and I say, oh, there's only one force acting in the x direction. So that is my net force in the x direction equals ma. Divide both sides by 50, and you get 0.6 meters per second squared. Does everybody agree with that? All right. So now we know the acceleration. Now part B and C, we're just doing step 5 of the procedure solved. And now we know what the acceleration is. So for part B, we want the final velocity. It started from rest. I believe it said that in the problem. V naught equals 0 plus 0.6 meters per second squared times 5 seconds. It would be good if in what's given, you actually write down the initial velocity equals 0. And then you plug in your values and you get 3 meters per second. Is that right? 0.6 times 5 is yeah, that's right. Okay. And then part C, using that same acceleration in time, well, V naught is 0, so this goes away. 1/2 a t squared. You plug your values in and you get 7.5. Does that make sense? I think so. Does everybody agree with that arithmetic? Okay. And so, very nicely done. Very nicely done. Any questions on problem 3? That is all.